Hello students, question number 1. When the force of 1 Newton acts on a 1 kg body that is able to move freely, the body receives. Yes, force F is equals to 1 Newton. Mass of the object is given as 1 kg. So from Newton's second law, we have F is equals to m into E, or A is equals to F by m. Substituting the value, we have force is 1 Newton, mass is 1 kg. That is 1 by 1, which is equals to 1 meter per second square. Therefore, body acquires an acceleration of 1 meter per second square. Question number 2. An 80 kg man stands on a spring balanced in an elevator. When it starts to move, the scale reads 700 Newton. What is the acceleration of the elevator? Mass of the man is 80 kg and the reading that on the scale, that is the reaction force, is 700 Newton. So let us consider this is an elevator. Here weight acts vertically downward, W is equals to m into g, and the reaction force by the elevator is in the upward direction. Let us consider that the elevator is moving vertically downwards with the acceleration a. Therefore, here the net force m into a is equals to mg minus r. Substituting the value, we have 80 into a, which is equals to 80 into 10 minus 700. So acceleration a is equals to 800 minus 700 divided by 80. That is, a is equals to 100 by 80, that is 10 by 8, which is 1.25 meter per second square. So we have considered elevator moving in downward direction. Therefore, the acceleration is 1.25 meter per second square in a downward direction. So option D is the right answer. Question number 3. A block of mass 9 kg lying on a frictionless table is connected to a block of mass 1 kg by means of a string which passes over a frictionless pulley as shown in the figure. What is the tension in the spring? So we have the two blocks of masses 9 kg and 1 kg. They are connected by a string which passes over the frictionless pulley. This is 1 kg. Let us consider this is mass m1. The weight acts vertically downward direction m1 into g, and the tension acts in the upward direction towards the support. Here 1 kg mass, its net force acts in a vertically downward direction, so acceleration is acting in downward direction. When you consider the 9 kg mass, the tension acts towards the support, that is T, and the acceleration is towards the right A. So writing the equation, let us consider the mass is m2, which is 9 kg. So we have the net acceleration for the 1 kg mass, that is m1 into a, is equals to m1g minus t. For the 9 kg object, we have m2 into a is equals to t. Let us consider this is equation number 1 and this is equation number 2. Add equation 1 and equation 2. We have m1a is equals to m1g minus t, m2a is equals to t. When we add the two equations, we have t and t get cancels. So m1 plus m2 into a is equals to m1 into g. So m1 is 1 kg, m2 is 9 kg into a is equals to 1 into 10, or a is equals to 1 into 10 is 10, 9 plus 1 is 10, which is equals to 1 meter per second square. We have acceleration is 1 meter per second square. Substituting in one of the equation, we have m1 is 1, acceleration is 1, is equals to m1 is 1 kg into 10 minus t, or t is equals to 10 minus 1, which is equals to 9 Newton. Therefore, the tension is 9 Newton. So, option D is the right answer. Question number 4. A ship of mass 3 into 10 to the power 7 kg is initially at rest, is pulled by a force 5 into 10 raised to 4 Newton through a distance of 3 meter. Assuming that the resistance due to water is negligible, the speed of the ship is. Here, mass of the ship is 3 into 10 raised to 7 kg and it is initially at rest. So, let us consider V naught is equals to 0 and is pulled by a force of 5 into 10 raised to 4 Newton through a distance x is equals to 3 meter. So, we have F is equals to m into A, or A is equals to F by m, that is 5 into 10 raised to 4 divided by 3 into 10 raised to 7, which is 5 by 3 into 10 raised to minus 3 meter per second square. Consider the kinematic equation V square is equals to V naught square plus 2A into x. So, V square is equals to V naught is 0 plus 2, acceleration is 5 by 3 into 10 raised to minus 3 meter per second square. The distance is 3 meter. So, 3 get cancels. So, V square is equals to 2 into 5 is 10 into 10 raised to minus 3, which is equals to 10 raised to minus 2. Taking the square root, we have V is equals to 10 raised to minus 1 meter per second or 0.1 meter per second. So, option C is the right answer. Question number 5. Two masses of 10 kg and 20 kg respectively are connected by a massless spring as shown in the figure. A force of 200 Newton acts on 20 kg mass. At a certain instant, the acceleration of a 10 kg mass is 12 meter per second square. The acceleration of 20 kg at that instant is. So, we have two objects, 10 kg and another one is 20 kg. They are connected by a massless spring and we have the force acting on the mass 20 kg is F is equals to 200 Newton. Here, since the force is applied on to 20 kg mass, the restoring force acts on the spring, which is given by K into X. Here for a 10 kg object, it is K into X. So, the restoring force Fr, which is equals to Kx, which is equals to force, which is mass into acceleration. So, when you consider here for the 10 kg object, that is 10, mass is 10, acceleration of the 10 kg object is 12. So, which is 120 Newton, the restoring force acting is 120 Newton. Here, when you consider the 20 kg object, the net force here, the F, applied force is F, the restoring force acts in this direction, Fr, and the net acceleration is acting in this direction. So, F net is equals to F minus Fr. F net is m2 into A, which is F is given 200 Newton. Restoring force we have calculated 120. So, acceleration A is equals to 200 minus 120, that is 80, divided by mass, that is 20, which is equals to 4 meter per second square. So, acceleration of the 20 kg mass at that instant is 4 meter per second square. So, option A is the right answer. Question number 6. A cricket ball of mass 150 gram is moving with a velocity of 12 meter per second and is hit by a bat so that it is turned back with a velocity of 20 meter per second. The force of blow acts for 0.01 second. What is the average force exerted by the bat on the ball? So, the mass of the ball is 150 gram, that is 150 into 10 raised to minus 3 kg, and it is moving with the initial velocity which is v naught 12 meter per second. It is hit by the bat and turned back, so final velocity is minus 20 meter per second, and the time of impact is given as 0.01 second. So we have to find the average force. We have impulse F into T is given by the change in momentum m into v minus v naught. So F is equals to mass is 150 into 10 raised to minus 3, v is minus 20, v naught is 12, it is minus 12, divided by time is 0.01 second, that is 150 into 10 raised to minus 3 into minus 32 divided by 0.01, we can write it as 10 raised to minus 2. So which is 15 into 32 into 10 raised to minus 2 by 10 raised to minus 2. 15 into 32 is 480 Newton, minus 480 Newton. So the magnitude of the force is 480 Newton. So option C is the right answer. The question number 7. 3 light strings are connected at a point P. The weight W is suspended from one of the strings, and A of string AP and NB of string PB as shown in the figure. In equilibrium, PB is horizontal and PA makes an angle 60 degree with the horizontal. If the tension in PB is 30 Newton, then the tension in PA and the weight are respectively. Here we have two strings AP and PB. So if you consider the figure, the first string makes an angle of 60 degree with respect to the horizontal. Now this string is AP and the second string is considered as PB, and the tension acting here is 30 Newton. Along AP the tension act towards the support, let us call it as T1. Here the tension T2 is 30 Newton. Here the weight is suspended vertically downwards. The weight is acting in the vertically downward direction mg. So this is a weight. Now here let us apply the Lami's theorem. It states that each force is proportional to the sine of the angle between the other two forces. So here we have, this is 60 degree alternate angle, this angle is also 60 degree. So the total angle of our triangle is 90 degree. So this is 60. So this should be 30 degree. So this angle is 90 degree. So applying the Lami's theorem, we have each force is proportional to the sine of the angle between the other two forces. So we have the weight W divided by sine of the angle between the other two forces, that is 90 plus 30, that is sine 120, which is equals to the next force is T1 divided by sine of the angle between the other two forces, that is 90 degree, that is sine 90, which is equals to T2 divided by sine 90 plus 60, the angle is 150, so it is sine 150. So let us consider the any two forces, that is W by sine 120. I can write this as sine 90 plus 30 is equals to T2 by sine 90 plus 60. So we have sine 90 plus theta is cos theta, W divided by cos 30 is equals to T2 by cos 60. So we have W is equals to T2 value, we have 30 Newton 30 into cos 30 is root 3 by 2 divided by cos 60 is 1 by 2. So 2 get cancels. So we have the weight is 30 root 3 Newton. Next we'll find T1. So we have T1 by sin 90 is equals to T2 by sin 150. So we have T1 is T2 into sin 90. Sin 90 is 1. So T2 into 1 divided by sin 150. Again we can write this as sin 90 plus 60. T2 value is given, which is 30 into 1, that is 30, that is cos 60. Sin 90 minus theta, cos theta, that is cos 60. Cos 60 value is 1 by 2, so it is divided by 1 by 2. 30 into 2 is 60, so T1 value is 60 Newton. Weight is 30 root 3 Newton and T1 is 60 Newton. So option C is the right answer. Question number 8. A machine gun fires 20 bullets per second into a target. So N is given as 20 number of bullets fired. The time is 1 second. Each bullet weighs 150 gram. So mass of the each bullet is 150 gram, that is 150 into 10 raised to minus 3 kg. Has a speed of 80 meter per second. So its speed is 80 meters per second. V naught is 800 meter per second. What is the force necessary to hold the gun in position? So we have impulse is F into T, which is the change in momentum, m into v minus v naught. So F is equals to mass is 150 into 10 raised to minus 3. Velocity, the final velocity is 0 minus 800 divided by time is 1 second. So it is 150 into 10 raised to minus 3 into 800 by 1, and for the 20 bullets it is into 20. So we have 15 into 2 into 10 square into 10 raised to minus 3 into 8 into 10 square. So we have 15 to the 30. 30 into 8 is 240. So 240 into 10. 10 raised to 2 plus 2 is 4 minus 3, that is 10, which is equals to 2400 Newton. So magnitude is get negative. So magnitude of the force is 2400 Newton. So option D is the right answer. Question number 9. A body of mass 10 kg is placed on a horizontal surface, is acted upon by a force of 129.4 Newton. If the acceleration of the body is 10 meter per second square, the coefficient of kinetic friction between the body and the surface is. So we have the mass of the body, which is 10 kg, and it is acted upon by the force, which is 129.4 Newton, and the acceleration is given as 10 meter per second square. We have to find what is the coefficient of kinetic friction, mu k. So here we have a object of mass m. So force is applied, acceleration acts in the direction of the force applied here. Here, since the object is moving towards the right, the frictional force acts towards the left, Fk. So we have the net force m into A is equals to F minus Fk, the frictional force. This ma is equals to Fk, frictional force, is nothing but mu k into n. Here n is nothing but m into g mu k into mg. That is, weight acts vertically downwards, normal reaction vertically upwards, so n is equals to mg. So substituting here, it is F minus mu k into mg. So m is 10, acceleration is also 10 meter per second square, force is 129.4 Newton minus mu k into 10 into 9.8, that is 100 is equals to 129.4 minus 98 into mu k, or mu k is equals to 129.4 minus 100 divided by 98, that is 29.4 by 98, which is 0.3. So mu k value is 0.3. So option C is the right answer. Question number 10. A 7 kg object is subjected to two forces in Newton, F1 and F2. What is the magnitude of the acceleration? We have the two forces F1 and F2. So we can calculate the net force. That is, the total force acting on the object is F1 plus F2. So we have 20 I cap plus 30 j cap plus minus 8 I cap minus 5 j cap. So 20 minus 8 into I cap plus 30 minus 5 into j cap, which is 12 I cap plus 25 j cap. So this is 20 25 j cap. So when we take a magnitude of the force, F is given by square root of 12 square plus 25 square, that is square root of 144 plus 625, which is root of 769, which is 27.7 Newton. So we have F here. So force is given by m into a. So acceleration is F by m. F value is 27.7 divided by mass of the object is 7. So which is equal to 3.9 meter per second square, approximately 4 meter per second square. So option B is the right answer. Question number 11. A block of mass m has been placed on an inclined plane. The slope angle theta of the plane is such that the block slides down the plane at a constant speed. The coefficient of friction is. So we have a inclined plane. Let us consider the angle of inclination is theta. Here the block is placed on the inclined plane and it moves with the constant velocity v. Therefore, the acceleration is 0 since the velocity is constant. So, when we consider here, the weight of the object acts in the vertically downward direction, m into g. So, if we take the component of the weight, this angle is theta. So, this will be mg cos theta, and this component is mg sin theta. And the normal reaction force acts in perpendicular to the surface in contact. So we have, since the object moves in a downward direction, kinetic friction acts in a vertically upward direction. So we have mg sin theta minus mu k into n, that is the friction force mu k into n, is equals to m into a. Here acceleration a is 0, therefore we have mg sin theta minus mu k n is mg cos theta is equals to 0. Here n is equals to mg cos theta. Therefore we have mg sin theta is equals to mu k mg cos theta. Here mg get cancels on both the sides, so mu k can be written as sin theta divided by cos theta. Sin theta by cos theta is tan theta, so mu k is equals to tan theta. So option C is the right answer. Question number 12. A bird is in a wire cage which is hanging from a spring balance. In the first case, the bird sits in the cage, and in the second case, the bird flies about inside the cage. The reading on the spring balances. We have to find when the reading on the spring balance is more, whether when the bird is sitting or when the bird is flying. Now when you consider when the bird sits, suppose if you consider this is a cage, when the bird sits in the cage, here the normal reaction is nothing but here the weight of the cage plus the weight of the bird. This is a normal reaction, that is n is equals to weight of the cage plus weight of the bird. Now when the bird starts flying, the normal force exerted by the bird on the cage becomes 0. That is when bird starts flying, normal reaction force exerted by the bird on the cage becomes 0, that is n becomes 0. When the bird flies, what happens is the weight is carried by the air. Therefore, the reading on the cage is less when the bird is flying. Therefore, option A is the right answer. So, when the bird is sitting inside the cage, the reading on the spring balance is more, and when the bird is flying, it is less. So, option A is the right answer. Question number 13. The position time graph of a particle of mass 0.1 kg is given. What is the impulse at t is equals to 2 seconds? Here the xt graph is given. So along the x-axis it is time, along the y-axis it is position. It is changing in with respect 2 meters, 2, 4, 6, and here it is 2 second, 4 second and the 6 second. We know that when you consider the slope of the graph, slope of xt graph gives the velocity. So if you find the initial velocity, that is initial velocity vi is equals to x by t. So if you consider from this is a, this is b, you consider the slope AB. So we have x by t, that is 4 divided by 2, which is equals to 2 meter per second. If you consider from B to C, the velocity is 0. It is at rest, so velocity is 0. So final velocity, let us consider Vf is equals to 0. We have impulse is nothing but it is a change in momentum. Impulse is change in momentum, that is given by m into Vf minus Vi. So here this is mass is 0.1, Vf is 0, Vi is 2. So 0 minus 2, so which is equals to minus 0.2 kg meter per second. So option A is the right answer. Question number 14. Two masses m1 5 kg and m2 4.8 kg are tied by a string hanging over a frictionless pulley. So we have two masses. The mass, let us consider the mass m1 and the mass m2. This is mass m2. So it is tied by a string and it is passing over a pulley. You have to find what is the acceleration of the masses when it is left free. So since m1 is 5 kg, which is greater than m2, so m2 is 4.8 kg. That is, m1 moves in the downward direction with the acceleration a, m2 moves in the upward direction with the acceleration a. So when you consider m1 here, the weight acts in a vertically downward direction m1 into g, and the tension is upwards, that is T. So writing the equation for the mass m1, we can write this as the net force is m1 into a is equals to m1 into g minus T. When you consider the second mass m2, here the weight vertically downwards m2 into g, and the tension is T, acceleration is upwards. So we can write the equation as m2 into a is equals to, along the direction of a we have T, that is T minus m2 into g. So add the two equations. When you add the two equations, we can cancel plus T and minus T. So we have m1 plus m2 into a is equals to m1 minus m2 into g. So acceleration a is equals to m1 is 5 minus m2 4.8 into g is, let us consider it as 9.8, divided by m1 plus m2, that is 5 plus 4.8. So 5 minus 4.8 is 0.2 into 9.8 divided by 5 plus 4.8 is again 9.8. Get cancels. So A is 0.2 meter per second square. So option C is the right answer. Question number 15. A player caught a cricket ball of mass 150 gram moving at a speed of 20 meter per second. If the catching process to be completed in 0.1 second, the force of the blow exerted by the ball on the hand of the player is equal to. So mass of the ball is 150 gram, that is 150 into 10 raised to minus 3 kg, and its initial velocity is vi, we can consider it as 20 meter per second, and the catching process is completed in 0.1 second. So when he catches the ball, the final velocity is equals to 0, it comes to rest. So we can apply the Newton's second law, that is F is equals to, or force, impulse is force into time, which is equals to delta P, or Newton's second law is F is equals to delta P by delta T. So we have force F is equals to m into Vf minus Vi divided by delta T. So substituting the values, 150 into 10 raised to minus 3, 0 minus 20 divided by 0.1. So which is equals to 50 into 150 into 20, 3000 into 10 raised to minus 3. 0.1 can be written as 10 raised to minus 1. So it is, when it goes to numerator, it becomes plus 1. So it is, we can write this as 3000 into 10 raised to minus 2, which is nothing but 30 Newton. So magnitude of the force, we have the magnitude of the force is nothing but it is 30 Newton. So answer option C is the right answer. Question number 16. A cyclist turns around a curve at 15 miles per hour. If it turns at a double the speed, the tendency of the overturn is. So they have given, let us consider v1 is v, v2 is 2 times the initial velocity. So when it is taking a circular turn, it is nothing but we have a force acting is the centripetal force, which is given by mv square by r. That is, F is proportional to v square. That is, if v doubles, if let us consider F1 is proportional to v1 square, F2 is proportional to v2 square. That is, v2 is nothing but 2 times the v1. So it is 4v1 square. So the tendency of the overturn becomes 4 times, or it is quadrupled. So option B is the right answer. Question number 17. A body of mass m is moving in a circle of radius r at a constant speed v. The force on the body is mv square by r and is directed towards the center. What is the work done by this force in moving the body over half the circumference of the circle? Now we have the body which is moving in a circular path. So here the centripetal force is acting towards the center. This is center of the circular path. Now when you consider here, the velocity acts along the tangent. That is, the displacement is acting along the tangent of the circular path. So we have work done is given by Fs cos theta, that is F dot S, which is Fs cos theta. So as I said, the displacement is along the tangent, that is along this direction, that this is the direction of the displacement. So the angle between the centripetal force and the displacement is 90 degree. So theta is 90 degree. So work done is Fs cos 90, cos 90 is 0. So work done is 0. So option B is the right answer.